Beyond the speed limit. The allure of warp drive. The universe is vast. Its distances are measured in light years. Even at the speed of light, it would take years to reach the nearest stars. But what if we could travel faster than light? What if we could warp space-time itself? This is the promise of warp drive, captivating scientists and fans alike. Imagine a spaceship bending the fabric of space-time, creating a bubble, compressing space in front, expanding it behind. This distortion propels the ship at incredible speeds, potentially faster than light. Warp drive is rooted in Einstein's theory of general relativity. While exciting, it presents significant challenges, from energy needs to exotic matter. The pursuit of this technology continues to inspire and intrigue, pushing the boundaries of our understanding. The fabric of reality, understanding space-time. To comprehend the mind-boggling concept of warp drive, we need to grasp the fundamental nature of space and time. Imagine a trampoline. This trampoline represents the fabric of space-time. Objects with mass, like planets and stars, create indentations in this fabric. These indentations are what we perceive as gravity. Now, imagine placing a bowling ball, representing a massive object, in the center of the trampoline. The bowling ball will create a dip, distorting the trampoline's surface. This distortion illustrates how massive objects warp the fabric of space-time. If you roll a marble across the trampoline, its path will curve as it passes near the bowling ball. This is analogous to how gravity affects the trajectories of objects in space. Now imagine creating a warp bubble around a spaceship. This bubble would essentially manipulate the fabric of space-time, compressing it in front of the ship and expanding it behind. This manipulation would create a difference in the slope of space-time, effectively propelling the ship forward. The key takeaway is that space and time are not separate entities, but rather interconnected aspects of a unified fabric called space-time. By understanding this fundamental concept, we can begin to grasp the theoretical possibility of warping space-time to achieve faster-than-light travel. Warping the cosmos, the mechanics of faster-than-light travel. The concept of warp drive gained scientific traction in 1994 when physicist Miguel Alcubierre proposed a theoretical model known as the Alcubierre drive. Imagine a spaceship enclosed within a bubble of distorted space-time. This bubble, according to Alcubierre's model, would contract space-time in front of the ship while expanding it behind. This contraction and expansion would create a wave-like motion, propelling the ship forward. The ship itself would remain stationary within the bubble, protected from the extreme forces generated by the warp drive. Visualize a surfer riding a wave. The surfer doesn't propel themselves through the water, but is carried along by the wave's motion. Similarly, a warp-driven spaceship wouldn't technically move through space, but would be carried along by the distortion of space-time itself. This concept allows for faster-than-light travel without violating Einstein's theory of relativity. This is because the ship itself wouldn't exceed the speed of light within its local space-time bubble. Instead, it would take advantage of the warped space-time around it to travel vast distances in shorter periods. While the Alcubierre drive provides a theoretical framework for warp drive, it faces numerous challenges. These challenges include the immense energy requirements and the need for exotic matter, a hypothetical type of matter with negative mass energy density. Section 4. Energy and exotic matter. The hurdles of warp technology. The concept of warp drive presents formidable challenges. One major hurdle is the enormous energy required to create a warp bubble. Imagine powering an entire city for a year. Now multiply that by an astronomical factor. Another obstacle is the need for exotic matter. Exotic matter has negative mass energy density. This is essential for creating the warp bubble effect. However, exotic matter remains theoretical and unconfirmed. These challenges highlight the immense hurdles to making warp drive a reality. Section 5. Paradoxes and possibilities. The implications of warp drive. The possibility of warp drive raises intriguing questions about the nature of time, causality, and the very fabric of reality. One of the most perplexing issues is the potential for time travel paradoxes. If we could travel faster than light, we could theoretically outpace the flow of time itself, potentially allowing us to travel backward in time. This raises the classic grandfather paradox. If you could travel back in time and prevent your grandfather from meeting your grandmother, would you cease to exist? Another mind-boggling implication is the potential for violations of causality. Causality is the fundamental principle that cause must precede effect. However, warp drive could potentially allow for situations where effects precede their causes, leading to bizarre and counterintuitive consequences. Imagine sending a message back in time that arrives before it was sent. This violation of causality would have profound implications for our understanding of the universe and the nature of reality itself. Despite these paradoxes and philosophical quandaries, the potential benefits of warp drive are immense. It would revolutionize space exploration, allowing us to reach distant star systems within human lifetimes. It would open up unprecedented opportunities for scientific discovery, resource acquisition, and even interstellar colonization. Section 6. A long way to go. Current research and future prospects. The quest for warp drive is still in its infancy. While the theoretical framework exists, we are nowhere near possessing the technological capabilities to manipulate space-time on the scales required for faster-than-light travel. Current research focuses on exploring the fundamental physics of warp drive, particularly the nature of exotic matter and the energy requirements for creating a warp bubble. Scientists are investigating various theoretical approaches, including modifications to the Alcubierre drive model and alternative concepts such as wormholes, which are theoretical tunnels that connect different points in space-time. One promising avenue of research involves using powerful lasers to create microscopic warp bubbles in the laboratory. While these experiments are far from creating a warp-capable spaceship, they provide valuable insights into the behavior of spacetime under extreme conditions. Another area of focus is the development of advanced propulsion systems that could potentially bridge the gap between our current technology and the requirements of warp drive. These include concepts such as fusion propulsion, antimatter propulsion, and even more exotic ideas like spacetime manipulation through electromagnetic fields. The road to warp drive is long and challenging, but the pursuit of this groundbreaking technology continues to inspire scientific curiosity and push the boundaries of human ingenuity. While we may not achieve faster-than-light travel in our lifetimes, the quest itself is a testament to the boundless possibilities of science and our unyielding desire to explore the cosmos.